We will be skipping 4.3 and moving on to 4.4, but first we have to write the quadratic function in standard form. Remember, standard form is ax squared plus bx plus c. And anytime you see two parentheses being multiplied together with two terms, you should think FOIL. And when we FOIL, the F stands for first, or the first terms in each parenthesis. So we multiply x times x, and we get x squared. And then outside are the outside two numbers of our parentheses. So x times 3 is 3x. Then inside are the inside two numbers, so negative 5 times x is negative 5x. And last are the last, or L is last, the last two numbers in both parentheses. So negative 5 times 3 is negative 15. And the last part, we have to simplify and combine like terms. Remember, your x squared term goes first, so we have x squared. There's not another term that goes with that. The only two terms we need to combine are our o and I terms. So 3 minus 5 is negative 2x. And then we have minus 15. And this is a standard form of our quadratic equation. Again, remember, when we write in standard form, we go from highest to lowest for our exponents. So we start with 2, go to 1, and then we have no x's. So this is the standard form of our quadratic equation. So in 4.4, we're going to be factoring quadratic expressions, which is my favorite. We're first going to start with a equals 1 today, and then move on to a is greater than 1 the following days. So when we are factoring, we're rewriting an expression as a product of its factors. So just like the Bell problem, it had x minus 3 and x plus 5. Those are the factors of our quadratic expression. So when you think factoring, you should think two parentheses most of the time. The greatest common factor, the GCF, is the common factor in terms of the expression. So if I had 2x plus 6, I have to look to see if they had any number that could divide both these numbers and so that it a whole number, which would be 2. So our greatest common factor is 2. Then we have a perfect square trinomial, a trinomial that is a square of a binomial. And then we have a difference of squares, which if we factored this out, would be a plus b and a minus b. So when we are factoring, it's doing FOIL backwards. We need two numbers that multiply to be c, but add to be b. And we're going to put those into two parentheses. So again, we need a sum of m and n must equal b, and the product of m and n must equal c. So when we're factoring these expressions, since the number out front of our x squared term is 1, we can already put this into two parentheses. And the first step is to split up your first term, which is x squared. Since we have two parentheses, that means each parenthesis will have an x in the first term. And then we need to determine two numbers that multiply to be 20, but add to be negative 9. So since our last number is positive and our middle number is negative, that means both of our numbers must be negative. And two numbers that multiply to be 20 but add to be 9 are 4 and 5. And that is how you factor this expression. This next one, again, excuse me, we can already break it down into parentheses. Since our x squared term has a 1 in front of it, split up your first term. But we need to find two numbers that multiply to be negative 12 but add to be 3. So we'd have 1 and 12, 2 and 6, 3 and 4. None of those combinations will give us 3, so this expression cannot be factored. So I'm going to give you a little bit of a time to factor these expressions, come back, and hopefully you have the correct parentheses. For the first one, the factors are x plus 4 and x plus 5. Again, notice how both of your signs are positive. That means both of the signs in your parentheses will be positive. And for the second one, your 2 will be x plus 18 and x minus 4. Since one of the last term is negative, that means one of your terms must be negative. But since our middle term is positive, it means our bigger number must be positive. So next we have to determine what is the greatest common factor. And we have to figure out what this expression is in factored form. So again, when we figure out the greatest common factor, we look to see what do they have in common. So first look at the numbers. What number could we divide 6 and 9 by and still get a whole number? Hopefully you thought 3, so we can take out a 3. And then look to see if they have any variables that in common. One has x squared and one has x, so we can take out 1x. And then we got to figure out what we are left with. So when we figure out what we're left with, it's like you're dividing both terms by your greatest common factor of 3x. When you do that, 6 divided by 3 is 2. So those are done. And we have 2 x's, and we divide by 1, so we're left with an x. If you notice, our x's cancel out on this term, but 9 divided by 3 is 3. If you don't like doing it that way, you can think of it this way. Start with your greatest common factor. 3 times what gives me 6, which is 2. And I have 1x, I need 2 x's, so I need another x for your first term. And then move on to your second term. 3 times what gives me 9, which is 3, which is what we have here. And I have an x, I only need 1x, so I'm done. For this next one, figure out your greatest common factor, which is 4. When you take out a 4 from all of these terms, we're left with x squared plus 5x minus 14. But look to see that we can still factor this out. So since our number up front of our x squared term is now 1, we can have our 2 parentheses. Remember, you split up your first term, so we have x and x. And one number will be positive and one will be negative. But the bigger number must be positive since our middle term is positive. And we need 2 numbers that multiply to be negative 14, but add to be 5, which are 7 and negative 2. Do the same thing for the last one. You should find your greatest common factor of 9, and you're left with x squared plus x minus 2, which can still be factored. So our final factored form is 9, x plus 2, and x minus 1. So we have a couple special factoring patterns. The one I'm going to focus more on is the difference of 2 squares. So if you look at our example here, we have x squared minus 4. Notice how we don't have that middle x term like we do here. Since we do not have that, you take the square root of both of your terms. So if we take the square root of x squared, those cancel out, we're just left with x. So we put that in the first spot. And then we take the square root of 4, which is 2. So we put that in the second spot. And since we don't have this middle term of x, we have to have a positive and a negative of the same number to eliminate that. So to factor these expressions here, again, we're going to have our 2 parentheses. Taking the square root of your first term, the square root of x squared, square and square root cancel out, you're left with x. And if you take the square root of 49, you get 7. And remember, we don't have that middle term, so we'll have 1 positive and 1 negative. Our next one, B, if you don't recognize that it is a special pattern, you split up your first term. And we need 2 numbers that multiply to be 36 but add to be 12, which are 6 and 6. And they'll both be positive. So you can either write it like this, d plus 6 twice, or you can write it as d plus 6 squared. So this is a perfect square trinomial because you can write it as a square of a binomial. And you can do the same thing for the second one, and you would get z minus 13 squared. So go ahead and factor these out, taking out your greatest common factor of 4 for the first one, and you should get 4, and in parentheses x minus 3 squared. And then for the bottom one, you should notice that 64 and 1 are perfect squares, so our factored form would be 8x minus 1 squared. So these are the best ones that we can do. I love talking about these. Again, 25 and 49 are perfect squares, and it's a difference. Remember, you can only do this when you have a difference. The square root of 25x squared is 5x. So that goes in both parentheses first. And then we have 49. The square root of 49 is 7. And remember, need to have plus and minus of the same number. And do the same concept for the bottom. The square root of 16x squared is 4x. Square root of 81 is 9. So your two parentheses are 4x minus 9 and 4x plus 9. And we're working on that problem in class tomorrow.